A great pleasure to introduce to you Professor Paul Berkman from the United States originally, but now, as you can see in your list of participants, the head of the Arctic Ocean Geopolitics program, University of Cambridge. He was trained as an oceanographer. Paul did his Ph.D. on Antarctica. He's a fellow of the National Science Foundation, an overall distinguished scholar. He has led several expeditions to Antarctica. He has done scuba diving under the ice, and he's still sitting here. He is publishing and authoring books on science and diplomacy and relationships to Arctica and Antarctica. About the science and governments of international spaces, those spaces which are not part of national sovereignties. And he has lived abroad in Japan for a year and New Zealand, etc. So it's my very, very great pleasure to introduce now to you, give the floor to Professor Paul Berkman. Paul?
Good morning, ladies. Good morning, everybody. Thank you, Gunnar. It was good. I will work on a transition here, so the slides that you showed at the end are where I'm starting. I'm going to talk to you about environmental security in the Arctic Ocean, and much of what I will present today is framed in a recent workshop that was sponsored by the NATO Science for Peace and Security program with co-directorship from Russia. This workshop was convened at the University of Cambridge in October, and there will be a book coming out from Springer next year. There's also a recent publication on environmental security from the Royal United Services Institute, in which the foreword was written by the Supreme Allied Commander for NATO. So in terms of environmental security, for the definition, since it's a term that's been used for many decades, I make no assumptions of trying to summarize anything, but think of it in terms of practical discussion. So for the purposes of this presentation and for the purposes of the recent workshop at the University of Cambridge, environmental security is defined as an integrated approach for assessing and responding to the risks as well as the opportunities generated by an environmental state change. And I'll go over what I mean by an environmental state change in a moment. These risks are characterized in terms of political, economic, and cultural instabilities that are defined as events or operations requiring governments to allocate resources in an unplanned manner or at the expense of previously prioritized activities. These resources could be financial, diplomatic, or intellectual capital, as well as tangible assets that are relevant to the security and welfare of the governments and the human populations they represent. In terms of the Arctic Ocean, it seems useful to place this in terms of context. So working from first principles, this is the Arctic Ocean basin. Like any system, it's characterized by its boundaries, effectively the sea floor, the continents on the side, and the sea surface, which is in terms of sea ice. We have inflow and outflow from the North Pacific and the North Atlantic, and forcing from the sun. The system is also characterized in terms of its solar regime, and so one opportunity in terms of characterizing what the Arctic Ocean is, not in geopolitical terms but in actual ecological or environmental terms, is the region north of the Arctic Circle. This is convenient both for operational purposes as well as the region that is influenced by the solar regime. In terms of the system itself, there are the coastal states who have self-identified themselves as coastal states: United States, Canada, Denmark, Norway, and Russia. And clearly, Iceland also is a maritime state in the Arctic region. There are two states that are not bounded by coastal access: Finland and Sweden. And in addition, there are the indigenous peoples of the Arctic. These groups represent the originators of the Arctic Council, which I will go into later, which is seen as a high-level forum to discuss Arctic issues. In terms of the environmental state change in the Arctic is going from a permanent sea ice cap, which has been there for at least the last 800,000 years, to a seasonally ice-free sea. So in effect, it's like removing the ceiling of this room. The boundary conditions of the system are changing, so the system itself is fundamentally going into a new state. The figures you see on number A, or letter A, is a profile of the ice thickness seen from upward-looking sonar, and what you see is the thickness of the ice is thinning over time. B is a profile looking downward on the surface of the ice, and what you see is the areal extent of the Arctic sea ice is decreasing over time. And C is a model that suggests somewhere in the middle of the 21st century the sea ice in the Arctic Ocean will be gone during the summer. And it is that projection about what will happen in the middle of the 21st century that is largely setting in motion the types of interests and activities that are emerging around the world. In addition, if you look more closely at the composition of the ice, what we see is that the Arctic is going from a region that has historically had multi-year ice to a region that is now predominated by annual ice. This is significant in terms of the rate of potential operations and activities in the Arctic. It's long been assumed, or recently been assumed, I guess, that the sea ice is going to be retreating so that it's open water across the Arctic during the middle of the 21st century. Operationally, however, there is capacity to use single first-year sea ice in terms of transit without icebreakers, but ice-strengthened vessels. At a recent meeting in Korea, there is interest on the part of countries that are major shipbuilding entities to begin providing access to new vessels, which they can turn out on the order of 30 months. So the question is, in terms of the sea ice, operationally, whether the entities would operate only during the summer, which is unlikely. More reasonably, they would create vessels that would operate throughout the year. In effect, one of the limitations may be the provisioning of ships to begin plying the Arctic. So that means that the Arctic today, in terms of its sea ice conditions with the predominance of first-year sea ice, may actually be in a position within the next decade to have an operational activity in terms of extensive shipping. Also, in terms of the rate of change, it is not the rate of lateral extent that is changing quicker. It is actually the thickness of the sea ice that is changing faster. So in terms of parameters, that is probably a more significant feature. In terms of the international dimensions of the Arctic, I mentioned the Arctic coastal states and indigenous peoples. However, there is a much broader international community of interest, long-standing interest in the Arctic region. The columns that you see highlighted in blue represent organizations that involve all of the Arctic states. So the AC is the Arctic Council, the Arctic Ocean Science Board, the Forum of Arctic Research Operators, the International Arctic Science Committee, the North Atlantic Coast Guard Forum, the Standing Committee of Arctic Parliamentarians, and the Spitsbergen Treaty. In particular, if you look at the Spitsbergen Treaty from 1920, you see that there are 42 countries that are involved since 1920. So as much as the Arctic states may define the interests of the international community as being relatively recent, there is actually a long-standing interest in the Arctic region, and it is broad among the various countries around the world. In terms of what is happening to the Arctic, I will use the notion of oil and gas as an illustration of where we are in the Arctic in terms of the international dimensions, and the notion of political, economic, and cultural instabilities that are emerging from the environmental state change. I take as an example a contrast between what happened in 1974 at the height of the OPEC oil embargo and the observations from the deep sea drilling program in Antarctica, where it was suggested that there were hundreds of billions of barrels of oil, trillions of cubic feet of natural gas on the continental shelf of Antarctica. At the time, it's suggested to be on the order of 25% of global energy potential. As opposed to today, where we're talking about the Arctic containing about 30% of the world's undiscovered gas and 13% of the world's undiscovered oil. The consequence in the Antarctic was that suddenly in the mid-1970s, international interest began to migrate southward to participate in the Antarctic in terms of the vast potential of resources. And as a consequence, the Antarctic Treaty Nations were forced to accommodate the interests of the broader international community. And over the next 15 years, they went through an accommodation phase where the Antarctic Treaty System effectively grew 300%. leveled off in 1991 when the Protocol on Environmental Protection was brought into force. Michel Rocard had a significant role in that environmental protocol. In effect, the Arctic is right at that transition between the establishment phase, where countries that are Arctic countries are asserting their sovereignty, sovereign rights, and jurisdiction, and organizations and entities around the world are expressing their interests in the Arctic, including the European Union, China, Japan, Korea, and so on. So in effect, the challenge is to bridge these interests in terms of who's actually in the Arctic and the broader international community. The solution that has been brought to the table in terms of frameworks is the UN Convention on the Law of the Sea, which identifies important rights and obligations of these different players across the world. Just briefly, progressing from the coastal zone, there is the territorial sea, going through the contiguous zone into the exclusive economic zone, and then beyond the exclusive economic zone is the high seas, which is defined as regions beyond sovereign jurisdictions. On the sea floor, we have the continental shelf, and then beyond the continental shelf is the area, or the deep sea. So in effect, the Law of the Sea Convention provides a gradient from nation-state interests into international space interests, interests that are on the part of the entire international community. If we look more closely at the Arctic in terms of the Law of the Sea Convention, in effect, the Arctic illustrates a balance, or a challenge to create a balance. On one hand, we have the well-distributed fixtures on the left of the sea floor, where potentially the entire sea floor of the Arctic Ocean is defined as continental shelf of the Arctic states, progress possibly all the way to the North Pole. Independent of whatever designations are given to the continental shelf, whether it's international space in terms of the area or national space in terms of continental shelf, in the overlying water column, in the center of the Arctic Ocean, is the high seas, a region beyond the exclusive economic zone. The high seas will exist independent of any designation of what happens to the seafloor. In effect, the Arctic represents this challenge in itself, the dichotomy between national interests as reflected by the seafloor and international interests or common interests as reflected by the overlying water column. The challenge we face in the Arctic, as well as globally, is one of balancing national interests and common interests. So I'd like to, since this is a presentation to ESA, I'd like to focus more specifically on a scenario and actually suggest an experiment. In terms of shipping, in 2009, the Arctic Council produced the Arctic Marine Shipping Assessment. The Arctic Marine Shipping Assessment was based on information that was collected in 2004, synthesized and distributed in 2009. It identified relationships of ships, ship tracks in terms of ecosystems and so on. However, one of the challenges in terms of any type of ship assessment is that the data themselves are comparable over space and time so that trends can be interpreted. The Arctic Marine Shipping Assessment provided a description of what was there, but it didn't actually interpret the trends. And so I have a student that is working on this and has reprocessed the Arctic Marine Shipping Assessment information from 2004 with the idea of testing what the relationship is between sea ice extent and ship density. These type of information has to be acquired and distributed over timescales for operational decisions. So this is an area where organizations like ESA, JAXA, NASA, etc. can provide collaboration. In terms of the shipping, the black line that you see there is the actual sea ice extent in 2004, and the various vertical lines are the sizes of the vessels. And what the student was hypothesizing is that the extent of vessel traffic was inversely related to the sea ice extent. So as the sea ice decreased, the amount of vessels in the Arctic, the size of the vessels would increase. And this is what he found in terms of the size of the vessels. If you look more closely in terms of the number of vessels, again, you see exactly the same trend. So this is just based on an analysis from 2004 in terms of ship density in relation to sea ice. In order for this type of analysis to be more robust, these type of data have to be collected over time. It's insufficient to have data collected in 2004 and published in 2009, for example, if operational decisions have to be made on the order of weeks or months. So that means that we have to have systems in place in order to provide real-time information so that operational decisions can be made. And so I would provide a sense of an experiment. The challenge is to provide real-time, synoptic, full basin coverage for operational and scientific interpretations. In terms of the experiment, it would involve configuration and assessment to produce a constellation of satellites, European, Russian, United States, China, Japan, Canada, etc. One of the challenges itself is to create an experiment that robustly identifies the network of remote sensing capacity and reconciles it in a way that provides productive information in a real-time manner. In terms of assessment, that constellation would be assessed in terms of the international networking, the progress and the processes of creating the dynamics between these different space agencies. A significant feature would be the costs of putting this constellation up there so that that can be appropriately accommodated in terms of national budgets. In terms of costs as well, if the Arctic is to become a trade route, a significant trade route that would cut a third of the time of transit from the Suez Canal or Panama Canals, like the Panama Canal, Suez Canal, there are costs associated with it. It's unrealistic to expect that the Arctic states would have an unfunded mandate to accommodate world traffic through the Arctic region. So one of the sense of costs may be that there would be a cost recovery capacity in terms of activities across the Arctic Ocean that would go back into providing this constellation. In terms of the periodicity, I mentioned, let's see if I go back a second here. If you look at the Arctic in the upper left-hand corner, you can see that across the Arctic Ocean in March is basically first-year sea ice. And given the capacity of ships to transit across the Arctic in first-year sea ice, it's possible that today there is a route from the Bering Strait through the Barents Sea using first-year sea ice. So any type of experiment in terms of remote sensing would need to have a seasonal component. So I just suggested in terms of March and September period during the middle of the winter and during the summer. So that assessment would involve the seasonality. In terms of the sensors, surface vessel reflection, being able to detect vessels remotely as opposed to surrounding sea ice or icebergs, use of automatic identification systems and being able to have the appropriate sensors to capture the ships in terms of where they are in their position, various sea ice parameters in terms of extent, reflectivity, etc., ocean atmospheric coupling, and other components in terms of sensors that would be brought to bear in terms of this constellation. And the assessment there would be the functionality and the processing of the information. So in a sense, the Arctic is going through an environmental state change. There is a need for international collaboration and cooperation, coordination, to understand how to respond to this environmental state change. The solutions will involve national interests balanced with common interests. It is unrealistic to assume that the Arctic states themselves are alone going to be able to provide stewardship for the international community as a whole, which means that the international community has responsibilities to assist in understanding how to contribute to safe, secure, reliable activities in the Arctic region. I have no other points, but if there are any questions, I'd be happy to answer them at the moment.
Thank you, Paul. We have 10 minutes before the coffee break for any question addressed to the two speakers or to comments, or who would like to start? Not yet enough information? Yeah. Stephen.
Thank you, Isabel. My name is Stephen Briggs. I'm head of Earth Observation Science Applications and Future Technologies here at ESA. Just staying with your last slide, Paul, I think it's a very interesting experiment, but I'm not sure it's really such an experiment. I think we're quite a long way along the road to providing that as a routine mechanism. Certainly the Earth observation aspects of it, the remote sensing aspects, particularly from radar systems, are now fully functioning, and in the years to come with the Sentinel program through GMES, we will have the sort of capacity for multiple imaging of the Arctic at the appropriate resolutions on a routine basis frequently to be able to provide that component of that system anyway, which you're looking at. We have also the continuing passive microwave radiometers from SSMI, SMMR and so on, together with more specialized sensors on cryosat and so on. So I think that quite a lot of the infrastructure and the technology which is needed to implement what you're suggesting should be done here is either available now or will be available in the very near future. I know that Norway has plans also for an AIS, satellite-based AIS system, which in fact more than plans, it's in operation now. So I think, I suspect much of the components of what's needed for this are probably either there or will be there very shortly, and it's really a challenge to put these together. I think it's the system engineering is the task rather than the creation of the components, and that's not a trivial task in its own right.
And that was my sense. In terms of capacity, probably the most difficult challenge is going to be one of bringing these different components together in a way that can be used for operational decisions. I was in Moscow in September, and Vladimir Putin spoke of the interest of Russia to increase their remote sensing capabilities. And I know that China and Japan are similarly interested. In a sense, the partnership is a broad one, and bringing these different sensors together, not just for the purposes of Earth system observation, but actual decision making and how to allocate resources for infrastructure to accommodate the activities is a component, and there may be a cost recovery component to that in terms of future activity.